Okay, here's an example that we're going to go through. What I've done is I've carried out a reaction and I've collected a certain amount of gas over a period of time that was formed or produced. We notice at time zero, there is no product because that makes sense. The reactants still have not yet collided to form that product. So this line is representing a product, not a reactant. If it was a reactant, then we would start off with some at time zero, and that reactant would get used up over time. So I know that this is a product line. I want to make note of my axes is time in seconds, and the y-axis over here is volume of gas collected in milliliters. Sometimes this will be a concentration, but in this particular graph, it is volume. What I want to do is I want to take the average rate over a given period of time, and I also want to calculate the instantaneous rate. So what I want to do is I want to select a time interval, and I could say, for the first 8 seconds, what would the average rate of the reaction be? So what I do is I find where 8 seconds is, right here, and I make a little dot on my curve. And if I'm going over the first 8 seconds, that would be from 0 to 8 seconds, I draw a secant line. Now that represents the average rate over that time period. What I want to do is I want to get values at that time period, at time 0 and at 8 seconds. So what I'm going to do is I'm going to draw a line that sort of intercepts the y-axis, and obviously at 8 seconds, I also want to draw a line going down, okay? So I'm going to figure out that calculation in a moment. The other part of this reaction that I want to figure out is the instantaneous rate at exactly 2 minutes. So at a specific moment in time, I want to figure out that rate. Because really, at a moment in time, here's 2 minutes, what I want to do is I want to just sort of draw a line up to that curve. And when I go up, okay, there's my 2-minute mark there. I want to draw a tangent line where it is a line that just hits at that 2-minute mark. And I want to extend that line into the y-axis, okay? So what you then want to do is you want to figure out a slope value of this straight tangent line. And what you do is you extend your line so that, it hits at a point. So I like that it's stopping here at the 1.6 milliliter mark. So what I'll do is I'm creating a rise and a run. So where I want it to stop. So here I'll have it stop at this point here where it extended to, okay? So then what I want to do is just draw dashed lines going down as well. And I'm going to calculate average rate and instantaneous rate. So I've already got those lines sort of dashed out for us here. What we're going to do is we're going to look at the average rate, the orange line. And when I do that, you have to calculate the slope of that line. And the way that we do that is we take y2 minus y1 all over x2 minus x1. What I notice is my y2 value is 1.9 seconds, 1.9 milliliters, and my y1 is 0 milliliters. My x2, so at 1.9, what is that x value? It's 8 seconds, and we know that at x1, we're at time 0. So then what you want to do is you want to do 1.9 minus 0 divided by 8 minus 0 on the bottom, and you end up with a value of 0.2375. The top is my milliliters per second. Now, obviously, that's a lot of significant digits. I think based on the values that I've collected here, I can only be accurate to one significant digit. So that would be just 0.2. So let's go back and take a look at that tangent line that we drew at the 2-minute mark. So when we take a look at where we extended our tangent line to, we try and make it, intercept that y-axis again, and then we sort of stop it at any point. And I want to stop it at 1.6 milliliters. So at 1.6 milliliters, the time that I record is between 3.5 and 4 seconds, which is 3.75. And then we see that where it intercepted the y-axis is at 0.3 milliliters. And so at 0.3 milliliters, the time is 0. What I do is I do the same equation that I did before in terms of calculating the slope. So I take y2 minus y1 over x2 minus x1. We can see that the values 1.6 minus 0.3. So that's where the volume went to. This is where it started in terms of that tangent line. And then it was at 3.75 minus 0. And again, we're getting those values right from where we stopped and started that tangent line. When I do that calculation, we end up with a value of 3.74 milliliters per second. Now, what that's telling me is that at the 2-minute mark, the rate of the reaction in the production of gas is much quicker than if I was to take a look at the average rate over 8 seconds. This is much slower. So this makes sense to me because as we take a look at this particular curve, the steepness of the curve is starting to change. And so what we look at is the slope of the line. The slope of the line is greater as we start out, but then as we keep going, the steepness actually lessens. So that means the slope of the line is also getting smaller. And so the smaller the slope of the line, the slower the rate of the reaction. And when we come to a plateau, that means that your slope will be 0 and the reaction has come to a stop.